Hello and welcome to EE-Craft. In today's video, we will explore a microprocessor board that can run AI applications. Artificial intelligence, or AI, is already making an impact on our daily lives. In the future, it is expected to bring significant changes to various aspects of our lives. While there is some skepticism about whether these changes will be beneficial or detrimental, AI has shown promising results in improving productivity when utilized in a constructive and positive manner. To learn how to build AI applications, developers should start with a microprocessor board that has adequate resources to support the development of AI algorithms, such as deep neural networks. There are several options available, and we can choose the one that best fits our requirements. In this video, we introduce one of these boards from Sipeed, called Maix Bit 1. It is a compact development board designed for simple audio and video applications. The board features a Kendryte SoC that integrates machine vision and machine hearing capabilities. The Maix Bit 1 board version 2 includes a USB driver, allowing connection with various supported IDEs. It also has a MEMS microphone, one RGB LED, flash memory, and more. Let's explore the features of this board in detail. K210 is the first generation of system-on-chip processors developed by Canon Incorporated, released in 2018 and aimed at the AI on the edge market. This SoC features dual 64-bit RISC-V processor cores, which can operate at a maximum frequency of 400 MHz. It also includes a neural network hardware accelerator, known as the Neural Processing Unit, capable of performing convolutional neural network operations with high efficiency. This board from Sipeed, which features integrated machine hearing and machine vision capabilities, might be a great starting point for learning AI concepts. Though, in the current video, we will show you how to get started with this board. Please note that there are newer and more advanced IoT-capable boards available from Sipeed and a lot of other companies. The Maix Bit board is outdated and should not be used in new projects, as it may be phased out soon. Additionally, it is important to mention that EE-Craft does not intend to promote Sipeed boards and has no business relationship with the company. This video is created solely to generate educational interest. Let's revisit the features of the Maix Bit board. In addition to the K210 processor, the Maix Bit board is equipped with 128 kilobytes of serial flash memory. It also includes a USB to UART driver chip CH552, a 24-pin connector for a DVP camera, a connector for an LCD display, and a micro SD card connector located on the bottom side of the board. The version 2 Maix Bit board. It features an installed MEMS microphone for audio applications. Additionally, the board includes an RGB LED, which will be utilized for this demonstration. Also note that it comes with a USB Type-C connector. The high-level specifications are shown here. One point to note here is this board does not support Bluetooth communication. Let me take a pause for you to scan through. Before we power up the board, I want to mention that we are having difficulty finding a compatible camera. The Sipeed website does not provide detailed information about any third-party cameras that would be compatible with this board. It simply states that any standard M12 camera should work. For the Maix Bit board, it mentions that a specific model OV2640 with a DVP interface would be suitable. We hope to find the right information on a compatible camera by the time we make the next video about this board. On the back side of the board, the only component present is the connector for the micro SD card. Currently, we're using a 16 GB micro SD card. However, we could not find any information regarding the maximum supported size of the micro SD card for the Maix Bit. Okay, let's power the board up and run an application. Certain steps must be performed for first-time users of this board, and let me walk you through them in sequence. The first step is to connect the board to the computer's USB port using a USB Type-C to Type-A cable. The red LED indicating that power is okay lights up. After a successful power-up, we need to check whether the computer detects the USB to UART driver chip it is connected to. We did not have a driver for the CH552 chip installed, which is why the board was not recognized on any COM port. It's important to note that the driver chip on the version 2.0 Maix Bit board with a microphone is different from the USB to UART chip on the version 1.0 board. The driver for the chip CH552 can be downloaded from the website provided and installed. After a successful installation, the board will be recognized as connected to a COM port. After installing the appropriate driver, the board is now recognized on COM port 18. Once the board is detected on the COM port, we need to update the firmware of the Maix Bit board using the latest version available on the GitHub page. To download the firmware onto the Maix Bit board, we first need to download software provided by Sipeed called K210. In the GUI, we need to select the firmware file for the Maix Bit board. The rest of the settings can remain at their default values. You can find a firmware on the web page displayed. Links are also provided in the description box for your convenience. Make sure to select the correct firmware in the K210 GUI. Then click the download button to begin flashing the Maix Bit board. It will take half a minute to download the firmware. Next, we need to choose a suitable IDE software to write our application program for the Maix Bit and upload it to the board. This board is compatible with the Arduino IDE, Platform.io IDE, and MaixPi IDE. The latter is developed by the same company, Sipeed. In this video, we have chosen the MaixPi software to demonstrate how could run a program in the Maix Bit board using the MaixPi software. The Arduino and Platform.io IDEs allow programming in C or C++, whereas MaixPi is compatible with MicroPython. For Maix Bit, an earlier version of MaixPi must be used. The link is available in the description box. You can find the details of the MaixPi software on the web page provided here. As mentioned earlier, the Maix Bit board is compatible to MaixBit V1 software. The links to the software installation files are also included. This is how the MaixBit IDE GUI looks. As mentioned earlier, the programming language supported is the MicroPython programming language. Let's select the Maix Bit board from the Tools menu and choose Select Board. Note that the board used in this video includes a microphone and is version 2. We have additional menus that we will explore in upcoming videos. There is a terminal window at the bottom where we will communicate with the board over the COM port. We can toggle this window on and off like other tools. We can also select various settings to customize the appearance, text sizes, colors, etc. We're going to execute an example program that lights up the onboard RGB LED and changes its color at regular intervals. Additionally, the program will read the input from GPIO3. It will also print the values of the red, green, and blue outputs, as well as the GPIO3 input values to the serial port. As you can see, it works flawlessly. In our upcoming video, we will show how to record audio using the onboard microphone and save it to the microSD card. This is a small step forward before we begin working on an audio machine learning project. Feel free to check out other videos on this channel. See you in our next video. Thanks for watching.